geometry, we're going to be dealing with circles and arcs. Now, this is probably the first time that we've really dealt with the word arc and what it means. So today, there's going to be a lot of vocabulary. Some of it that involves circles should be review. Most of it that involves arcs is probably going to be new vocabulary. Now, first of all, radius is something that we've heard before. And I'm going to take some time and go through the vocabulary that are on here. But if you are someone who was absent today, this is a time where I would probably hit pause on my record, and I would probably sit down and write down all of these vocabulary words and make sure they were in my notes. Later on, they're going to ask you about them, so if you don't know what they are, you're going to kind of be stuck behind the 8-ball. So first of all, if I talk about a circle, they usually draw some kind of a circle with a dot in the middle and call it P. P would be the center point. And usually circles are named by their center point. Now, a radius is anything that goes from that center point out to the circle. So that means that this PA, PB, or PC are all radiuses. The thing about radiuses is they're all equal. And actually the word isn't radiuses, it's radii when there is more than one. So if I'm talking about congruent circles are ones that have equal radii, or have a radius in one that's equal to a radius in another. Now, diameter. Diameter is when it goes all the way across a circle. So from A to B. The central angle is the angle where the vertex point is actually at the center. So P is our center. So a central angle would be one that has P in the middle. And the two endpoints actually on the circle. So C, P, B would be an example of a central angle. Now also, if I deal with a semicircle is half a circle. So in this one, a semicircle would be if I drew a line here from S through T and we looked at one half of the circle, either above or below. That would be a semicircle. An arc is part of a circle. So that goes from like T to R. So just this part. Now, a minor arc is one that's less than halfway or less than a semicircle. A major arc is one that is bigger than 180 degrees. So if we were looking at this circle up here, the semicircle is TRS. Now notice there's 3 letters, and they've kind of drawn an arc over that. The measure of that's 180 degrees. So when you talk about an arc, you're going to measure it the same way you would with something else with actual degrees. Now, if I want a minor arc, RS up here would be a minor arc because it is, I can see, less than halfway. Also, if I want to deal with a major arc, it has to be one that's bigger than 180 degrees. So if I was looking at this, RTS would be a major arc because it goes more than halfway around the circle or more than a semicircle. So let's take a look at some examples. So in this circle, let's go through and try to identify things. So first of all, if I'm talking about minor arcs, I want arcs that are less than 180 degrees. So I want to look around and name as many as I can. So first of all, probably the 2 easiest to see are AD and CE. Those are probably the easiest. Now, AD is going to be my first one here, so I'm going to have those 2 letters with the arc symbol over it. Now remember, I could have wrote that as DA as well. This one will be CE with the arc over it. Now remember, it could be EC. Now I want to find some other ones, so if I look, A to C is less than halfway. And then DE. Now, if I were to look for semicircles, I want to look at halfway. And an easy way to look at this is if you could find a diameter. Like DC I can see is the diameter, which means that CAD has to be a semicircle. So CAD. And don't forget, you can also do the bottom half. So CED would kind of be the bottom half of that one. Now that's just from one diameter, so let's try this one. if I go from A to E, that segment is a diameter. So if I go to look at this now, ACE would be another one. Or if I did EDA. Remember, they have to have arcs over them. So if you look for that piece right there, it might be a lot easier to look at that semicircle. Now, a major arc that contains the point A. So remember, a major arc is one that has to be greater than 180 degrees. So a major arc that contains A, if we did A as the end point, I have to go more than halfway. So I have to go more than E. I'd have to go all the way to D. So I'd have to go from A to D. So if I do that, I have to leave at least one point in between. So if I were doing that, I could do A, C, D, or I hope you can also see that A, E, D is that same arc. Now that's one. Now if I find another major arc, if I go the other way, so if I go from A through D to E, E's halfway. So if I go to C, that would get me more than halfway. So again, I could do A, D, C, that could be one. I could also do A, E, D. One of the things that's pretty important when you're naming these is you want to make sure that if you're naming something, you want to have a point in between if you can. Like if I did AD and that was all I wrote, I wouldn't know really if I was going this way or this way. Most of the time they're going to assume if you're doing AD that you're only talking about the minor arc. Most of the time if you're talking about a major arc, they're going to put another letter in the middle like we did here. Okay, now let's try where A is just part of it. So let's say that we were going to start at E. If I went from E and went around to A is halfway, but I'd have to go all the way to C for it to work. So I would do E, A, C. Now, I know I could name this E, D, C, and that would still be true, but remember they wanted A in there, so really they're going to want this one. Okay. Let's try one more with a starting point at D. So if I started at D, D, A, C would give me a semicircle, so I'd have to go to E to get past that. So that means I could do D, A, E. Okay, let's take a look at the next ones. Again, a little vocabulary, so I'm going to go through this quickly, but if you're somebody who needs to hit the pause button once I get done with this, please do. So first of all, arc addition is when I add two smaller pieces to get a bigger one. So on this one, if I want to take arc AB and I want to add to it BC, oh sorry, my highlighters are trying to go straight even when they're not here. There we go. Okay, so if I go from A to B and B to C, if I took those pieces and added them together, I should get what the distance is to go around here. So I'm just going to kind of color code this, but it's the idea that you can take two littler pieces and add them together to get the bigger one. Now also in this section, we're going to deal with circumference, and this is probably something we haven't done in a while. So notice first of all that if a circle's going to be talked about in any way, you're going to see pi used. So a couple things. If you don't have pi in your calculator, in this section they are going to expect that you use the pi key, unless they're going to tell you to use pi to be is approximately 3.14. Most calculators have a pi key in them, so check yours out where it's at. Okay, and then you can see whether you're using, the actual button or what we're going to use. Now, on this one, they have two formulas. This one has a diameter in it, and pi. And this one has two radiuses. So I just want you to think back to that picture we talked about with the circle. Two radiuses equal a diameter. So you can use either formula. It really just depends on the one that you're given. So if you're looking at this problem here and you want to find the circumference, then they're actually giving me the radius here. So that means it's probably going to be to my advantage to use this formula. And I know in this one that my radius is going to be 6. So if I take this and plug this into my calculator, so 2 times pi times 6. First of all, if I were to do this kind of the easy way, if I took 2 and 6 and multiplied them together, that would be 12 pi. Now this is what's considered to be in terms of pi. Some questions are going to ask us that later on. So if I were doing this, remember circumference is the distance around a circle, the perimeter of the circle. So the easiest way probably is to say that, this could be 12 pi feet. If I wanted to actually put this in my calculator to solve it, if I put 12 pi in there, I'm going to get, hang on, my pen went to highlighter, 37.7 feet. So depending on the kind of answer they want, you're going to have to look if it's in terms of pi or if it's round to the nearest tenth. A lot of them are round to the nearest tenth. Okay, now, in B that's down here, you can see that that's a diameter. So that would probably make sense to use this formula. So I know the diameter is 18. So if I plug it in there, this, if I added meters on it, this would be the in terms of pi answer, 18 pi meters. Now if I were to put that in my calculator and round it to the nearest tenth, it would be 56.5 meters. So again, look at the kind of answer they want from you. Okay, let's see if I can do this one rather quickly. We've only got a few minutes left. Define the area of an arc. Now remember, they're talking about the length of this arc right there. If I know what the actual measurement is for this angle, if I know what's going on in here, that's only part of my circle. So if I divide that by 360 and then multiply it by the circumference, I can find what the length of just that piece is. So let's take a look at how this works. So I'm going to set up the problem just like the one up there, except I'm going to leave this spot for the measurement of the angle out. And I'm also going to leave out the radius. So in this problem, this little square right here tells me it's 90 degrees. So 90 is going to go in there. Now if my diameter is 16, that means my radius is 8. Okay, now, two things that we have to be careful of. If this answer is in terms of pi, I'm going to multiply and divide all of this stuff together and then stick that pi on the end. So I would do 90 divided by 360 times 2 times 8, and I would get 4 pi. So 4 pi inches would be my answer in terms of pi. Now if I were to really put that in my calculator and multiply it out, I would get 12.6 inches. So again, look at the kind of answer they want you to do. Okay, let's see if we can fit this one more in here. So on this one, I'm going to set it up the same way. So 360 times 2 times pi. Now in this one, I can tell that my radius is 15 and my angle for this arc is 240. So again, my problem is do everything that's here except for that pi. So 240 divided by 360 times 2 times 15 will give me 20. So 20 pi centimeters would be in terms of pi. If I put that in my calculator, it would be 62.8 centimeter. So please look at the form. They